Creola Katherine Johnson was an American mathematician whose calculations of orbital mechanics as a NASA employee were critical to the success of the first and subsequent U.S. crewed spaceflights. During her 33-year career at NASA and its predecessor, she earned a reputation for mastering complex manual calculations and helped pioneer the use of computers to perform the tasks. The space agency noted her historical role as one of the first African-American women to work as a NASA scientist. Johnson decided on a career as a research mathematician, although this was a difficult field for African Americans and women to enter. The first jobs she found were in teaching. At a family gathering in 1952, a relative mentioned that the National Advisory Committee for Aeronautics was hiring mathematicians. NACA hired African-American mathematicians as well as whites for their guidance and navigation department. Johnson accepted a job offer from the agency in June 1953, according to an oral history archived by the National Visionary Leadership Project. At first she worked in a pool of women performing mathematical calculations. Katherine has referred to the women in the pool as virtual computers who wore skirts. Their main job was to read the data from the plane's black boxes and carry out other precise mathematical tasks. Then one day, Katherine were temporarily assigned to help the all-male flight research team. Katherine's knowledge of analytic geometry helped make quick allies of male bosses and colleagues to the extent that they forgot to return me to the pool. While the racial and gender barriers were always there, Katherine ignored them. Katherine was assertive, asking to be included in editorial meetings. She simply told people she had done the work and that she belonged. From 1953 to 1958, Johnson worked as a computer, analyzing topics such as gust alleviation for aircraft. Originally assigned to the West Area Computer Section supervised by mathematician Dorothy Vaughan, Johnson was reassigned to the Guidance and Control Division of Langley's Flight Research Division. It was staffed by white male engineers. In keeping with the state of Virginia's racial segregation laws, and federal workplace segregation introduced under President Woodrow Wilson in the early 20th century, Johnson and the other African-American women in the computing pool were required to work, eat, and use restrooms that were separate from those of their white peers. Their office was labeled as colored computers. In an interview with WHRO-TV, Johnson stated that she didn't feel the segregation at NASA because everybody there was doing research. You had a mission and you worked on it, and it was important to you to do your job and play bridge at lunch. She added, "I didn't feel any segregation. I knew it was there, but I didn't feel it." NACA disbanded the colored computing pool in 1958 when the agency was superseded by NASA, which adopted digital computers. Although the installation was desegregated, forms of discrimination were still pervasive. From 1958 until her retirement in 1986, Johnson worked as an aerospace technologist, moving during her career to the spacecraft controls branch. She calculated the trajectory for the May 5, 1961, spaceflight of Alan Shepard, the first American in space. She also calculated the launch window for his 1961 Mercury mission. She plotted backup navigation charts for astronauts in case of electronic failures. When NASA used electronic computers for the first time to calculate John Glenn's orbit around Earth, officials called on Johnson to verify the computer's numbers. Glenn had asked for her specifically and had refused to fly unless Johnson verified the calculations. Johnson later worked directly with digital computers. Her ability and reputation for accuracy helped to establish confidence in the new technology. In 1961, her work helped to ensure that Alan Shepard's Freedom 7 Mercury capsule would be found quickly after landing, using the accurate trajectory that had been established. She also helped to calculate the trajectory for the 1969 Apollo 11 flight to the moon. During the moon landing, Johnson was at a meeting in the Pocono Mountains. She and a few others crowded around a small television screen watching the first steps on the moon. In 1970, Johnson worked on the Apollo 13 moon mission. When the mission was aborted, her work on backup procedures and charts helped set a safe path for the crew's return to Earth, creating a one-star observation system that would allow astronauts to determine their location with accuracy. In a 2010 interview, Johnson recalled, "Everybody was concerned about them getting there. We were concerned about them getting back." Later in her career, Johnson worked on the Space Shuttle program, the Earth Resources Satellite, and on plans for a mission to Mars. Johnson spent her later years encouraging students to enter the fields of science, technology, engineering, and mathematics. Johnson died at a retirement home in Newport News on February 24, 2020, at age 101. Following her death, Jim Bridenstine, NASA's administrator, described her as an American hero and stated that her pioneering legacy will never be forgotten.